Yes, so only Sarah has joined till now.
Yes, ma'am.
Your exams are going, no, Sarah?
Yeah.
So see, I'll begin the class. Let students join because it's already 5 minutes are over. So see, in the last class, we had started with motion under gravity. We couldn't complete all the questions of it because of lack of time. So one or two questions were left, which I'll complete it today. So under motion under gravity, the new thing or the different thing that we study is, see, it's just that gravity acts and acceleration becomes your acceleration due to gravity, which is 9.8 meter per second square, or which we can round it off if needed as 10 meter per second square. This is what we take. Now, apart from this, we had studied regarding the sign convention. Now, today we'll be studying about relative velocity also. So, relative velocity also based upon the sign conventions. Now, see, when we are talking about motion under gravity, everything which is moving upwards, you take it as one sign, and everything which is moving downwards, consider as one sign. But always remember, direction of acceleration due to gravity, this is going to be downwards only. So whatever direction you can choose, upwards as positive, downwards as negative, anything. This question we
Can I ask something?
Yes, Sarah.
Is there any integration in the second chapter, motion in a straight line?
Motion in a straight line, yes. Motion in a straight line has.
In which part?
Remember when we had that integration class, I had told you, if velocity is given to you and distance is asked, if this is asked, then we differentiate. Remember, dx over dt gives you velocity. If this is asked, displacement is asked and velocity is given, then you bring this term over this side. So integration of dx becomes v dt. This part only.
Okay.
Fine. Remember, just check your notes. You had attended the class, no, of motion, that integration one. Yes? Yeah. So you must have written it in your notes. Wherever velocity is asked, acceleration is given, then you integrate. Wherever you have to come back to the function. From displacement, if you want to jump to velocity, you differentiate. But from velocity, when you want to jump back to displacement, then you integrate. This is like this. Now coming back to motion under gravity. So see, this question we discussed. Let us discuss this question. These types of questions are asked in the exam. Now see, this says that a ball is thrown vertically upwards with a velocity 20 meter per second from the top of tower. So again, from the top of tower, with velocity 20 meter per second. This is the initial velocity, a ball is thrown. Height of the tower this time is given to us. So height of the tower, let's say this was the tower, this is ground. So total height is 20 meters, 25 meters, 25 meters. This is given as 25 meters. This is asking us how long will it be before the ball hits the ground. So see, let's take sign convention. You can choose any sign convention. Let me take upwards as positive and downwards as negative. So initial velocity, ball is moving up. So initial velocity will be first upwards. That is 20 meter per second is there. But what would be the sign? Since it is upwards and we have chosen upwards, so it would be positive. Acceleration due to gravity, we have studied acceleration due to gravity will always act downwards no matter what. So acceleration due to gravity, this will be, and in this question, let me take this as 10 meter per second squared. This is acceleration due to gravity, which is coming downwards. Now, and yes, height is also given, displacement is also given. See, the ball is coming downwards. The ball was moving, the ball is coming downwards. So if the ball is coming downwards, the displacement is also downwards, right? So instead of writing just as 25 meter, I'll write displacement also negative. All right, had I chosen downwards as positive, these two would have been positive and this would have been negative. That doesn't matter. You can choose anything which you want. This I have discussed it with you as well. Now see, only time is unknown. So yes, which equation should I use according to both of you?
B is equals to U plus AT.
We will use which equation, Sarah?
V is equals to U plus AT.
Final velocity is not given to us. V is not given. Using just this is your acceleration.
S is equals to UT plus 1 by 2.
Yes. S is equal to UT plus half AT squared. If you have all these equations in your mind and you are able to apply, half of your questions are solved here also. Rest are just calculation, and if some error you commit in the calculation part, then half marks are only deducted. But if the method is wrong, equation is wrong, then it becomes a problem. So it's good that you are able to identify the equation. See, S is given, U is given, T is unknown, A is also given. We do not have any information of the final velocity. That's why we want to avoid it. So this is minus 25 is equal to plus 20 we took. T is unknown, plus half. Acceleration is minus 10 because that is acceleration due to gravity, and again T square. So this becomes, if I write this equation, this becomes minus 25 is equal to 20T minus 5T square. Let's take 5 also common from this equation. Now this is just equation for you. In your 10th standard only, you have just come from 10th standard, so you know how to solve this equation, though I'll tell you again, but this is your answer. Now from here you have to find out T, that's it. But I'll solve this because here this involves splitting the middle term. So if you have forgotten it, it would be a revision if you are stuck with these equations. Let me take 5 common from here. If I divide the entire equation by 5, I'll be left by minus 5 here, 4 here, because 5 into 4 is 20, and 1 here, so minus T square. This is the equation. Let me bring the minus term over that side. This is just to solve it. Question has been solved, T has to be found. If the equation was simple, I could have used this only. But since this involved T square, T also, quadratic equation it is, right? So this won't be solved in one single step. So let me bring this term over. So T square minus 40. T square minus 40 minus 5 is equal to 0. Now if you splitting the middle term, T square, this becomes T, take common from here, T, or write it first, minus 5T plus T minus 5 is equal to 0. This is how we split the middle term. In 10th standard only, I think you all have, or in 9th. I think in 10th only you have this.
Yeah.
Right? Okay, so T will be common from here. What will be left with? T minus 5. From here, nothing is common, so plus 1, T minus 5. Yes. Now see, one value is T plus 1, one value is T minus 5 is equal to 0. Now see, two values of time is there. Two values of time are there. How to choose? What is the value of T from here? If you look at this, the value
minus
of T
1
becomes minus 1, right? And from here, this becomes plus 5 seconds. So which time according to you is right?
5 seconds.
5 seconds, because time cannot be negative. One option will definitely come in such a manner that you will not be able to identify. And yes, I'll tell you one thing. One question is there where you will get both the time. You get both the values positive. Suppose this answer was T minus 1. So we would have got T is equal to 1 seconds. In such cases, no, when you get both the second, because questions are there, I have seen questions in your 11th class only. So what do? Write both. It can be T is equal to 1 seconds or 5 seconds, just in case you're getting. Most of the questions do not involve this. You usually have one option getting, but just in case if you get it in your exam, then this is the best way. Asara, when is your physics exam?
On Monday.
Monday. So T is equal to 5 seconds is the answer. Quickly note it down.
Can you scroll? Done, ma'am.
Siddhika also completed? Siddhika? You're there in the class, Siddhika? Yes or no? No response from Siddhika. Siddhika, if you're listening in the class, just respond with a yes. Fine, then one last question is left from this segment, which comes a lot. And it's actually a very lengthy question, but this won't take a lot of time. Yes, Sarah. Sarah, you're asking something? All right, Siddhika. Siddhika, when is your physics exam? And Yasir, when is
Ma'am, I already did it. I
you
had
have
it
given
this
it?
week. Yes, ma'am.
Oh, so
Although I'm having another class test. I'm having another class test next week. Motion in a straight line, just half of the lesson.
okay, only motion in a straight line is coming.
No, ma'am, this is another test exam. Just test, class test.
Okay, okay, this is a class test. So how was your physics exam?
It was okay, ma'am. There were some graphs I didn't understand. I'll send you the question paper.
Yes, yes. Send me the question paper, Siddhika.
I'll send it after class if it's okay.
Okay, send it me. Okay, and what about you, Yasir, and who has joined, Abdullah? What about your physics exam given? So how was your exam, Yasir and Abdullah? It was easy. Okay. And yes, Abdullah, do send me all those who have had their exams. No, then please. Okay, good then. Yasir, if your exam was also good. One thing then, Sarah, if your exam is on Monday, see the way Siddhika is also saying, graphs part is important. Questions are there from graphs part. So if your exam is on Monday, are you people available on Saturday? Because tomorrow you people have your exams here, Learnivio, the question, and do give the exam, especially Sarah. It would be a good practice for your upcoming exam. So I think one class is needed because then Sarah, after your exam, same thing will occur. Like Siddhika, because graphs were not discussed. We have to have a separate class on graph. 1 hour only it would take. So if you people are available on Saturday, 2 p.m. IST is fine by all of you? 2 to 3 p.m. we can have
maybe I might have some extra classes from school.
You are not available like at that time?
No, I come back at 3 p.m. UA time.
Okay, if you come at 3 p.m. because 3:30, 4:35, 5 p.m. IST, 5 p.m. IST if you are available?
Yeah.
5 to 6, can we have a class on Saturday? 1 hour class, I just want to discuss the graphs. So that all those who are having their exams also, otherwise your syllabus will also be lagging behind, no? So at least graphs part will be over. What about others? Are you fine by 5 p.m. IST on Saturday? Abdullah, Yasir, Siddhika.
Okay, ma'am.
Okay. Okay. Then 1 hour class, it would be questions on graphs only, because you people will have questions on graph in your exam. Fine. The last question from motion under gravity, because after this I have to do relative velocity with you. That also comes in exam. So you people didn't appear for the class assessment. Only Sarah informed me in the last class that she'll not be appearing for the class assessment as she was having her exam yesterday. But rest of you, Siddiqa, Yasir, Abdullah, all had left. This question had come in your class assessment also. It's an important question. Do mark it as important while writing. After I explain, no, then only write, because I'll give you sufficient time to note it down. Now see, this says that 2 balls are thrown simultaneously vertically upwards with a speed of 20 meters per second from ground. Means from ground, this ball has been thrown up and a ball has been thrown down. It's like I am throwing it up from here and one is being thrown down, but simultaneously. So there would be a point where both the balls will collide, right? There would be a point when the balls are moving, they'll collide at one point. One is coming downwards, one is moving upwards. Height of the tower means whatever is the separation between the balls from which the ball is thrown or from which the ball is thrown upwards, that is 40 meters. So it means separation between the balls is 40 meters with the same speed. Okay, both are having the same speed. It means 20 meters per second is the speed of both the balls. This is the speed, 20 meters per second. And this is the separation between them. Means this is 40 meters. Both the balls are thrown, they'll be meeting somewhere. At what points do the balls collide? And G, we have to take it as 9.8. C class, first understand the question. What is the question asking us? This is a tower, let's say. From here, one ball is being thrown upwards, which is A. So initial velocity is 20 meters per second. One ball is being thrown downwards, same initial velocity is 20 meters per second. Why are we studying it motion under gravity? Because motion under gravity is being used over here, firstly. Secondly, directions of initial velocities are different. If directions of initial velocities are different, you will be getting different sign conventions. That's why this question becomes important. Let's say, and yes, total separation between them is 40 meters. This type of questions have been repeated in the school exams also. Last year also in many schools it was repeated. Let's say we have to find a point where the balls meet. Let me take a point. Let's say this point. This is X. If this is X, can anyone tell me how much this will be? Entire is 40. I have just taken X from here, from the first ball. How much will be left? What will this be the separation be?
Sx.
40 minus X. Total is 40. You have taken X from here. How much will be left? 40 minus X. Yes, Abdullah. So total was 40. Let's say this separation is X. I want to find out X, right? So this is 40 minus X. Again, sign conventions. See, upwards, I'm taking it as positive. Downwards, I'm taking it as negative. Do mention it in your exams. Which side you're taking it as positive, negative. I'm again repeating. Mind this, because if you miss writing this, you will lose entire marks for the question. Your answer will also come correct. Your answer according to you will also be right, but you won't get a score because what is upwards to you is not being mentioned. It could be downwards, right? So just specified. Now, see one thing. We have discussed initial velocity, 20 meters per second, 20 meters per second. We have discussed the displacement that they'll be covering. One is covering X, another one is covering 40 minus X. Can anyone tell me if time taken for this ball to come here is, let's say, T, what would be the time taken by this ball to come at this point? This is the point where they'll collide. If the ball one takes T time to move here, what will be the time by this ball to reach this point? Can any one of you tell me? It's a question anyone can answer.
T2.
T, very good. See, if balls are colliding, right? If balls are colliding, T as well. Very good, Abdullah. See, reason is that, suppose, let's say, let's say Sarah is coming. Fine. I am also moving. I am saying Sarah and I collide at this point. If the time taken by me and Sarah isn't the same, will we be able to collide? If I am moving, let's say at 2 p.m. I reach this point, the forward point, and at 2 p.m. Sarah reached, then only we will be able to meet. If I say I am reaching at 2 p.m. and Sarah is reaching at 4 p.m., does that mean we are colliding? We can only collide when we both are reaching at the same time. Simultaneously means what? Simultaneously means the same. That's why T won't be different. We won't take T1, T2. T would be the same. Fine. So see, variables have been reduced. Time is there, one variable, and this X is one variable. This was X, we could have taken it as Y, but why to take it as Y when you have 40 minus X with you? Right, we have to reduce the variables. So this I'll write it also. When both the balls are projected simultaneously. This was just the key point of this. Now the question is easy. Till here only you had to understand, and till here only you have to solve the question by yourself in the exam. Then time taken by balls to collide with each other is same. That's it. Now we have to form equations for both the balls. Let's talk about one particular ball. Let's say first ball 1. Fine. Let us say ball 1. This ball. Upwards is positive, downwards is negative. Fine. This is the sign convention that we have decided. Initial velocity 20 meter per second. Initial velocity, should it be positive or negative according to this sign convention for this ball?
Positive.
Positive. Very good, Sarah. It should be positive because this is moving up. Fine. Acceleration due to gravity will always be not always be negative, it will always be downwards. And since I have chosen downwards as negative, this is going to be minus 10 meter per second square. I think it is mentioned in the question to take it as 9.8. Right, so, but I'm taking it as 10. Otherwise, the calculation will go very lengthy right now in the class. And displacement here is X, right? This ball had to cover X. And time is also T. T1 is also T. S1 is X. A1 is this. U1 is this. This is the data that we have for this ball. And S is equal to UT plus half AT square is the equation. Displacement, ball is moving up. So displacement will also be positive, right class? Ball is moving up. Displacement will also be positive. So X is equal to 20T minus 5T squared, right? 10 by 2 is 5. If you take it as 9.8, that would be 4.9. Do take it as 9.8 if 10 is not mentioned. Right now, I'm just taking it to ease the calculation in the class. Ball 2. Now, data and sign conventions for the ball 2. Yes, Yasir, can you tell me? What should I write? This is the ball second. This is the second ball. This is the first ball. Initial velocity. What should I write the initial velocity? Yasir. Magnitude is given. I want to know the according to this sign convention which I have chosen. What should I write for you two? Yasir. No answer, Yasir. Minus 20 meter per second. Very good. See, ball is coming downwards. Initial velocity is down. And I have taken downwards as negative. So this should be minus 20 meter per second. Now see the difference. Ball 1 was going up. So here it was positive. Ball 2 is coming down. So this is negative. Acceleration due to gravity. Siddiqa. Should I take G as minus G or plus G? What is the direction of acceleration due to gravity, Siddiqa? Upwards, downwards, minus G. Very good. Because this is always acting downwards. So this will be again, this will remain the same, minus 10 meter per second. I am again repeating minus 10. I am just taking for this class purpose. In your exam, do take it as 9.8 only. And displacement. Yes, Abdullah, can you tell me the displacement for ball 2? Abdullah? For ball 2, the displacement. Minus 20. No, Abdullah. You had only answered that this displacement is 40 minus x. The entire separation is 40. Ball 1 is covering x displacement. Ball 2 is covering 40 minus x. Displacement's magnitude will be 40 minus x. And what should be the sign? Minus 40 minus x or plus 40 minus x? No, they are not colliding halfway. See, Abdullah, if they are colliding halfway, why would have been we be solving this? The question is asking x. We have to find out x. At what points do the balls collide? So answer would have been straight away, I would have written 20 here. Since we do not know they are colliding at what point, whether it's half exactly or not, right? Yes. So now tell me, Abdullah, 40 minus x is there. Plus 40 minus x or minus for this ball? Just tell me minus plus. The rest I know you know. Minus. Very good. Because the ball is coming down, displacement is downwards, and I have taken downwards as negative. So it would be minus 40 minus x, right? And time again. Time will be similarly to this time. This will be t only. So s is equal to ut plus half at square. This chapter is full of just these equations only. That becomes, if we open the bracket, this becomes minus 40 plus x. So minus 40 plus x is the displacement, minus 20t is the initial velocity multiplied by time, minus 5t square is the value of acceleration divided by 2. Now we just have two equations. This is one equation. This is second equation, which we need to solve. So x is equal to 20t minus 5t square minus 40 plus x is equal. I'll write it properly. So it's two equations with two variables. You have studied in your lower classes, linear equations with two variables. This is 20t, sorry. This is minus 20t minus 5t square. So let's subtract this. If we subtract, signs will change. This is what happens. So this becomes plus, this becomes minus, this becomes plus, this becomes, this also becomes plus, right? So if this becomes x minus x, this will cancel. 20t minus 20, this is minus 40. Oh, this is now plus 40, sign has changed. 20t, this is plus 20t, that is 40t. Minus 5t square plus 5t square, they get cancelled. T is equal to 1 second. This is the time. Question is still not asking us the time. Question is asking us the displacement. Now we can put value of t in any of these two equations, one or two. Let's put x is equal to 20. T means 1 minus 5 t square, that is 1 square, which is 20 minus 5, which is 15 meters. If you put the exact value is 9.8 meter per second, answer is exactly around 15.1. So you will get this answer. Exact answer should be this. 15 I am getting because I had taken it as 10. Quickly note it down, all of you. Yes, one point here it is left I wanted to discuss. In the last class, I had told you time of ascent and time of descent. When it takes by the body to move up, this is time of ascent. When the body goes down, this is time of descent. So time of ascent is equal to time of descent, that I have told you. But see, in nature, when dissipative forces are present, like friction force is present, then it can happen. Time of ascent is different and time of descent is different. But friction will not be asked in your exam because friction is starting from your laws of motion. So all the questions prior to that, but in your objective questions or one marker you can have, can this be the case? So you should remember when air friction or any dissipative forces are present. Okay, note it down. Then we'll start with relative velocity. Relative velocity also same thing like motion under gravity. No particular formula is there. It's just that with questions practicing you will get it. Now coming to relative velocity. See, relative velocity is all about sign conventions. Take one side as positive, take the opposite side as negative. That's how you have to solve the questions. Just one thing that is new in relative velocity is 1D. This is in one dimensions, right? You will have it separately in projectile motion, under projectile motion. So this is relative velocity, that is relative velocity in one dimensions. Suppose this is one car, A. This is with moving with certain velocity, 10 meters per second. Let's say this is one more car, B. Fine. This is moving with, let's say, 3 meters per second. Fine. Both the cars are moving. If a person A observes the velocity from ground, this is the person. The person is observing the velocity from the ground. From here, the person is observing. Then we say this is the velocity of car with respect to observer. This is what you have to just understand. With respect to what? Rest of it is just subtraction. Fine. When nothing is mentioned, see, if I say the velocity of the car is 10 meters per second, that means a person is observing on the ground the frame of reference. Remember, in the starting of this lesson only, we had discussed about frame of reference. So frame of reference is ground. When the person sits inside it, so B will become what? Velocity of car B with respect to observer, but not on ground, within the car. Clear? This is how you take. Now, how to calculate relative velocity? We write it as VAB or VBA. If velocity of A with respect to B, just understand what is the meaning of this term. When we say no, velocity of A with respect to B, that means observer is in B. Means I am sitting in car B, car A is moving, and I am calculating the relative velocity. What is meant by absolute? Absolute means when something is solely present. This car is only present right now. No other car is present, just this car is present. And I am from ground, I am observing it to move. So whatever is the velocity of this, I'm able to observe it. That is V velocity of this car, VA, VB that we take. Suppose this car is also present and this car is coming here. Right? This car is also moving. So when both the car come into your frame, velocity is with reference to each other. Now suppose these two cars are present and I sit in this car. So according to me, this will be velocity of A with respect to B, like this. And if it's opposite, for example, I was sitting in car A and I am observing the relative velocity between the cars. So it will be velocity of B, means which I am observing, with respect to A, with the car in which I am traveling. This is what you take. Fine. So suppose these are two cars, A and B. VA is this. When I say VAB, that means velocity of A with respect to B. Your observer is in B. This is the case. If the observer is in A, then that will be VBA. Velocity of B with respect to A. Fine. This is it. Now, how to solve it? When you write VAB, velocity of A with respect to B, that becomes VA vector minus VB. This is not addition or subtraction of algebra that we take. This is vector subtraction. After this, we'll start with vectors only. Before we go into details of motion in a plane, we have to have the knowledge of vectors. This is vector subtraction. But in one dimension, the vector subtraction and the algebraic subtraction isn't different. That's why we don't need to understand vectors here. But keep in mind that they are not just getting subtracted. They are vectorically subtracted. How are they vectorically subtracted? How are vectors different? That we'll study later on. In the next class, we'll study it. Fine. Or if it is VBA, then this becomes VB minus VA. This is the formula which you have to remember. But one thing which you have to remember apart from this is that they apply sign conventions here. you have to keep in mind the sign conventions. For example, if the formula is VAB, which is VA vector minus VB, velocities are vectors. If this is the formula, car A, this is car A, is moving with velocity 3 meters per second towards the right. This is car B, moving with velocity, let's say 1 meter per second towards the left. Now, according to this formula, what should have been the answer? A is 3, B is 1, 3 minus 1, 2 meters per second. This should have been the answer according to this formula if I don't consider the sign conventions. Now look, when you keep in mind the sign conventions, let's say left I have taken it as negative and right I have taken it as positive. Suppose left I have taken it as negative and right I have taken it as positive. Let me rewrite it. Left as negative and right as positive. Now check your answer. VA minus VB. Velocity of A, VA. This is moving towards the right. This is moving towards the right. This will become 3. Fine. And this is moving towards the left. This will become, minus is already there. This is the formula 1. VA, VA, minus, minus. Now we have to put minus 1 here. Understood? Plus 3 minus minus 1. VA, this is VA minus minus 1. What is your answer? 3 plus 1, that is 4. Both are different. Let's take the other sign conventions also. Let's say left is positive, right is negative. Now keep it in the formula VA minus VB. What will be VA? Velocity of A is towards the right. So it will become minus 3. Then this minus sign. And what will be VB? VB is towards left. So plus 1. So what do you get? Minus 3 minus 1, that is again minus 4 meters per second. Both the answers are different from 2. None of the answers is matching this. Why are both the answers correct? Suppose one student has taken this sign convention. This is one set of sign convention. See, the person's answer is getting plus 4. Plus 4 means towards right. Answer is right. Second student, let's say the second student has taken this set of sign convention. Answer is minus 4. Minus is also right. So answer is right only. Whatever sign convention you have chosen, according to it, you are getting the correct answer. Right? So this sign convention you have to keep in mind. Otherwise, the formula is VA minus VB only. If it is VBA, that will become VB minus VA. Quickly note it from here.
Can you scroll?
See, this question says that two trains run on parallel straight tracks along north-south direction as it is shown in the figure. Okay, already the figure is given to you. One is moving towards north with velocity 30 kilometer per hour and another is moving towards south with velocity 50 kilometers per hour. So question is saying, calculate velocity of train A with respect to passenger in B. So see, one sign convention we have to choose. Let's say north, I'm taking it as positive, means moving upwards as positive. So downwards means moving towards south, this will be negative. First part is saying velocity of A with respect to B, right? Velocity of train A with respect to passenger in B. So what is the formula? VA minus VB. VA, velocity of train that is moving upwards. So upwards, I have taken it as positive. So this will be 30 plus 30, right? Upwards. Downwards. Downwards, I have taken it as minus. So this becomes minus 50. So this becomes 30 plus 50, which is 80 kilometer per hour. I have not converted it. I have left my answer in kilometer per hour. If you want, you can further convert it into meter per second by multiplying 5 by 18. Second part, that was the first part. Second part is saying velocity of B with respect to A. So velocity of B with respect to A will be VB minus VA. Velocity of B with respect to A will be VB minus VA. So VBA will be velocity of B, means the train which is coming. This is velocity of B with respect to A. So train which is coming downwards is 50. So that becomes minus 50. Right, this is minus 50 and this is plus 30. So this becomes minus 50 and this becomes minus. This is 30. So that becomes minus 50 minus 30, which is minus 80 kilometer per hour. This is kilometer per hour. Fine. So VAB, this is VA minus VB. Plus 30 by plus 30, because north we have taken it as positive. Plus 30 minus minus 50, because this is coming downwards. Fine. Plus 30 minus minus 50. So, and second part is saying VB means which is coming downwards, minus 50, because downwards we have taken it as negative, minus VA which is we have taken it as 30 plus 30. Fine. So minus 50 minus 30, that becomes minus 80 kilometer per hour. So that tells you the direction for both of the velocities. VAB, what is VAB? This is answer is coming positive. Positive is for the direction north. So it means the direction is towards north. 80 kilometer per hour towards north. Second part is answering minus 80. Minus is telling south, means minus 80 kilometer per hour towards south. This is the answer for the second part. So one more part is there in this. A monkey is running on the roof. Just a second, give me. This is saying a monkey is running on roof of train A with velocity 5 kilometer per hour with respect to passenger A. Now you have to find out the velocity of the monkey. See, it means this monkey is moving on the roof of this train. This is train A, 30 kilometer per hour. Fine. And velocity of monkey is also given to us. This is 5 kilometers per hour. So we have to find out the velocity of the monkey. See, this is the third part. Let's say VM, velocity of monkey with respect to ground. VM we have to find out, no, velocity of monkey. So velocity of monkey with respect to ground. Velocity of monkey with respect to ground. VMA means velocity of monkey with respect to the passenger A. That is, I think, given in the question, no? Velocity of, yes, with a velocity with respect to A means velocity of monkey with respect to passenger A. VMA, velocity of monkey with respect to A, is given to us. So this is, let me tell you what is this. This is velocity of monkey with respect to passenger A. Now see, we know we have to find out VMA is VM minus VA. This is what I have told you, the formula for relative velocity. This is what is the formula, Vm minus Va. Now see, understand each variable which is given in the question. VMA, velocity of monkey with respect to passenger A. This is given to us as 5 km/h. I'm not putting the sign conventions right now. Let us just find out the magnitude. Velocity of monkey, this is unknown. Velocity of train A. Velocity of train A is also given, 30 km/h. So this is also 30 km/h. Now coming to sign convention. Train A is moving towards north and I have taken direction towards north as positive. So this will be plus. And see, monkey is moving on the roof of it in opposite direction and the same direction. This is saying running off. Okay, nothing. If it is running on the roof, it means the monkey is also moving in the same direction towards the north. So this will also be plus. So only this quantity is unknown. Vm will become Vma plus Va. This is minus, it will become plus. So your final answer will become 5 plus 30, which is 35 km/h. Answer is coming positive. Positive sign is depicting towards north. Note down the question with the solution.
Okay, so in 1 minute, can you show the third sub question? Okay.
Sarah, you're asking something.
No, I just wanted the third sub question. I'm done.
Class, answer this question. Figure is also given over here. Yes, class, answer to this question. See, this says that a jet is moving upwards with velocity 450 kilometers per hour. It ejects the exhaust in the opposite direction with a velocity 1200 kilometer per hour with respect to the jet. You have to find out the velocity of burnt exhaust. See, velocity, let's take one sign convention. Let's take upwards as positive and let's take downwards as negative. Fine. So velocity of exhausts with respect to the jet. This is 1200 kilometer per hour given in the question. You're getting it as, what is your minus, upwards or downwards? That also mention. Then only I'll understand which direction you have written it as correctly.
Downwards.
Whether it's upwards or downwards, because it can be anything according to you. So VEJ, that is velocity of the exhausts with respect to jet, is 1200. And since this is going downwards, this will be negative. Velocity of jet, the velocity with which the jet is moving is 450 kilometers per hour. And this is moving up, so this is positive. So VEJ will be velocity of exhausts minus velocity of jet. This is minus 1200 is equal to VE is unknown. The exhausts are unknown minus, this is 450. So this becomes 450 minus 1200, which is up you have taken positive and down negative, right? Same answer I'm also getting, minus 50 kilometer per hour. Minus sign is indicating that this is exhausts are moving downwards. Quickly note it down, those who haven't written it. You are having exam tomorrow, Siddhika?
No, ma'am. I have to get going somewhere. I finished my exams today.
Okay, your exams are over. Fine, Siddhika. One just small question I want to do, and you can note it down later. You can leave then.
Okay, ma'am.
Okay, one small question. This I just wanted to do with all of you. See, this question, car A is moving with 10 meter per second, B is moving with 2 meter per second. We have to find out time taken by A to cross B. See, VAB, whenever you have relative velocities questions, so velocities will also be VAB, that is VA minus VB. Distance will also be SAB, that is SA minus SB. Acceleration will also be AA minus AB. So when we are talking about velocity of car A, that is 10 meter per second. Velocity of car B, this is 2 meter per second. So VAB is VA, that is 10 minus 2, because both are in the same direction. So this direction, let me take it as positive. So both will become positive. So this becomes 10 minus 2, which is 8 meter per second. So relative velocity is 8 meter per second, right? VAB is 8 meter per second. I have to find out, the question is saying separation between them is also, that is SAB is given as 100 meters. Time is asked to me. So see, in this question, how will we solve it? VAB will be equal to SAB divided by T. Time will be equal to distance divided, relative distance divided by relative velocity, which is 100 divided by 8. Time is 12.5 seconds. Note down this. One last question is left, but that I'll do on Saturday now only. One question from this heading is left. One question that I want you to practice. It's a little lengthy question also, but we'll do it in the next class. Saturday, we all will meet. Graphs, I basically want to do graphs with all of you. So graphs we'll do on Saturday. So Saturday, 5 p.m., 5 to 6 p.m. IST. And especially those who are having their exams, do join the class. It's compulsory. It's just an extension of today's class. Graphs is a portion included in your syllabus.
Done.
Siddhika, you can leave. You had to go somewhere, no? You can leave. Siddhika.
Yes, ma'am. I'm still writing.
Okay, okay.
Done, ma'am. Thank you. Goodbye.
Please log in into your accounts for the assessment. Assessment will occur on the app. Please log in. So both of you, I think three of you, all of you have written this, right? So you can log into your accounts on the app, give the assessment on the app. Abdullah, Yasser and Sarah. Okay, we'll meet on Saturday now, 5 p.m. IST. Thank you so much, class.